In this video you will learn how to solve a resistor network with resistors in parallel and in series. When resistors are connected in series, as you can see in the drawing below, you can calculate the equivalent resistance by adding up all the individual resistance values. Mathematically it's written this way. The current through each resistor is equal, so we can calculate the voltage drop across each individual resistor using Ohm's law. The voltage drop across the ends of the network is simply the sum of all voltage drops. For resistors in parallel there is a different approach. Here the inverse of the equivalent resistance is equal to the sum of the inverse of every individual resistor in parallel. So 1 divided over the equivalent resistance is equal to 1 divided over R1 plus 1 over R2 until 1 over Rn. Furthermore, for a parallel circuit, the voltage drop across each resistor is equal. Knowing this, we can use Ohm's law to calculate the current through each resistor. Now we know how to solve circuits with resistors in parallel and circuits with resistors in series. But how can we solve a network with both resistors in series and parallel? We take an example of a simple circuit, and we want to calculate the equivalent resistance. We simplify the calculation by grouping resistors in series and in parallel. This group shows two resistors in series. The equivalent resistance is R23 and it's equal to R2 plus R3. Now we can simplify the circuit and we have a group with just two resistors in parallel, R1 and R23. The inverse of the equivalent resistance from this group is equal to the sum of the inverse resistances of R1 and R23. Using simple algebra, we can rewrite it in this way. By replacing R23 by R2 and R3, we get the equivalent resistance expressed in R1, R2 and R3. With this principle, also more complex networks can be solved.